Okay, we're going to graph this polynomial function. So let's look at this. If I'm going to graph this, then I'm going to open up the xy plane. Those are my y's. These are my x's. So let's go ahead and label those. And now when we're graphing polynomials, there are a few tools that we can use. So we can look at the roots. That's just a fancy word for x-intercepts or zeros, right? So what's going to make my function give me a zero, right? Where am I going to cross this x-axis? Because that's when y is equal to 0. We can also use in behavior. So what happens as I move away from the origin, right? As I go to the left, as I go to the right, what's the function going to do? And then we can also use the y-intercept, right? Where do I cross this y-axis? Okay, so in our attempt to do this, it's in our best interest to put this in as factored form as possible. So is there a way that I could rewrite this function and break it down into smaller factors? And I immediately see that that's not possible, right? This is already a monomial, it's a straight line. It just so happens to occur twice. This is a straight line, that's a straight line. This is a quadratic function, so I might be able to pull two factors out of this, but I can't, right? There are no zeros to x squared plus 1, right? X squared plus 1 looks like that. The x squared function shifts up by 1 unit, and it never has a 0, right? So there are no real zeros to that part right there. So where are my zeros? So that term doesn't give me any. Of course, 1/9 is never going to be 0. What's going to make that one 0? Well, that'll be 0 when x is equal to 3, because 3 minus 3 gives me 0. All right, I get minus 1 from this term there, and minus 5 from that term there. So let's go ahead and locate that on our x-axis. So 1, 2, 3, minus 1 right there, and minus 5. So minus 1, minus 2, 3, 4, 5. All right. So now that we've dealt with the roots, let's think about end behavior. So if I were to multiply all of these factors out, I would end up with 1/9 x to the 6th plus some smaller stuff, right? Something x to the 5th plus something x to the 4th. But the most powerful term there will be the 1/9 x to the 6th. And I know that's what it's going to be because of this 1/9 right there. And then all of these x's just have ones in front of them. So the 1/9 will be the leading coefficient. And how many x's do I have? I've got 1, 2, 3, 4, 5, and 6. So it is an even degree polynomial and a positive leading coefficient, which means I know that my end behavior is going to be reminiscent of x squared, right? That's the function that I have in my mind when I think about even degree polynomials with positive coefficients. I think about x squared. My behavior as I move away from the origin moves towards positive infinity, and it grows without bound as I move to the right and as I move to the left. All right, so we're done with our roots, we're done with our end behavior. Now let's consider the y-intercept. So the y-intercept, where do I cross my y-axis? Well, x is 0 there. So what happens when I evaluate this function at 0? I get 1/9, 0 squared is 0 plus 1, 0 minus 3 squared, 0 plus 1, 0 plus 5. And we can go ahead and simplify this, hopefully. What do we get? A 1, a minus 3 squared, so that's a 9. A 0 plus a 1 is a 1. And a 0 plus a 5 is a 5. So what am I going to get here? That 9 will cancel with that 9. 1s times anything is just itself. So really, this is just 5. Okay. So I go up 1, 2, 3, 4, 5. And that's where I cross my y-axis. So now we're ready to connect this arrowhead with that arrowhead. So if I start from the left and I go down, I hit my root at -5, and I notice that -5 is a consequence of this x plus 5 factor, right? That's what gave me the 0 there. And that factor occurs once, so it has odd multiplicity, so I'm going to pass through that root. All right, I continue on my way until I hit -1. -1 is a consequence of the x plus 1 factor. That factor occurs once, so it has odd multiplicity. I will also pass through, which is good, because I needed to have a positive y-intercept. All right, I come back down, I hit my root at 3. That 3 is a consequence of this x minus 3 term. And that happens twice, right? So it has even multiplicity, meaning that we are going to touch the root and bounce back, which is good because I needed to end up here anyway. So this is a pretty decent idea using the techniques that we've discussed in algebra of how to graph this polynomial function. All right, hope it was helpful.